Welcome to the second session that I'm giving today. That's about PowerEL Cloud. So it's our journey from the data center centric point of view to a more cloud perspective and a cloud approach to what we offer as a platform. So who am I? I'm from Belgium. I have my own company. We are a member of the OpenPOWER Foundation since 2017. And as some of you may know from the introduction, I'm also a TSC chair as of this year. I'm involved in a lot of enterprise Linux and in a lot of the open source world. I like to keep things secure. I do virtualization in containers, and we do config management and DevOps, and we work on the hardware software side of the world. So this presentation will be about what we did and how we did it. To do that, I will give a brief introduction. So in 2005, we built a data center, as many companies were doing at the time. The infrastructure was quite rigid. It could take up to a month just to get the physical hardware, and that doesn't include the negotiating for the actual purchase. After we got the hardware and we actually got it racked and stacked and everything was up and running from a physical point of view, it could take another 2 weeks to get access to the network or to storage. Everything was bare metal. Everything was installed on the machine. We didn't actually have automation, so it was actual manual labor. Installing it from scratch, getting everything configured, getting everything up and running, which at the time was not maybe that abnormal, but there were already better ways of doing this. The company I worked for didn't have all those investments, and so we did what we could. And we saw very quickly what type of problems we had. If a machine had to change network, it could take again up to a week. If the storage wasn't configured properly or things weren't working, it would add more delays, and getting things done was very cumbersome. A lot of manual labor, a lot of paperwork, a lot of people that were involved, and it took a very long time. And so in 2010, a few of us thought we could do it better, and we built a company. And our idea was to get things done faster, to optimize a lot of these things from the operating point, from the hardware point of view, from the operating system, and from the application. And to do that, we actually bought a lot of stuff from the old data center and the company they had, and took a lot of their knowledge and tried to optimize and do things faster, get things done better. But we were still having that. It wasn't a real green field, it was a green brown field. So we took a lot of the existing stuff that the company had, that the previous company had, and we rebuilt around that. But we didn't start from scratch fully, which made the inception of the company and the actual getting things done quickly much easier, because those were already there in place. But on the other hand, it meant that our initial idea of getting things done faster and optimizations weren't there from the beginning in the field yet. And so it took us a few years to realize that doing only operations wouldn't be enough. And we actually had to start development, and we had to migrate our old systems from a data-centric point of view to a cloud point of view. And initially, we migrated to something cloudish. I wouldn't call it cloud at that point. We started embracing configuration management and automation. We started working on our own Linux distribution to enable us to have more control on what would actually be going on in that space, and have us optimize and run things as properly as we wanted and in the way we wanted it. And so we started this journey, and we started the migration from the old to the new. And then we embraced DevOps. And initially, we didn't actually understand what it was. Most of my friends were very active in the DevOps community, and so I listened to them. And initially, I learned a lot from them, and took a lot of those ideas and tried to apply them to our model and what we had done. But like most organizations, if you don't have a greenfield and you're starting with something, it means that you need to transform what you have to what you want to get, and that takes a long time. We started to understand the word rebuildability, and with that I mean that if you look at the old data center, your machines were pets. You actually installed them, you nurtured them, and you took care of them in such a way, because the configuration, the actual building up of whole that stack was a whole endeavor, and you did not want to do that again because you did not have the tooling around that. And even if you used maybe Kickstart or Pre-C to install the actual machine, the configuration was much more complex. And configuration management made that easier, and we were able to actually get things run faster. But rebuildability was more than that. It meant being able to build up the whole stack all over again. And to do that, you need to be able to build from metal up to the application layer. And again, this needs to happen in stages. So you start with the physical machine. Obviously, there is no automation there. You still need to buy the machine, get it racked. But once it is in the rack, it should be fully automated, from the actual installation of the OS to the virtual machines to the applications and so on. And so we try to make our automation automatic in such a way that today, if we put a machine into a rack, it basically configures itself, gets up on all the networks, and gets all its configuration from a central management point. And this means that we are also sure that if we ever replace machines with newer machines, we can have that automation working. It also means that in the older systems where typically clusters had to be exactly the same machines, now we don't need that anymore. Machines can be a little bit different because automation will figure that out. And we have other abstraction layers that can make it possible to reuse our existing infrastructure without having to fully change the infrastructure. And now that we have all of this, did we actually reach a real endpoint? No, because to do DevOps, or to even think about it, means that you have to embrace a new philosophy, a new culture, and there is basically no end to that. It means that you need to continuously optimize, continuously improve yourself, continuously keep innovating and enabling multiple players in there. So in the previous stage, we had optimized everything for ourselves from an operation and from a developer point of view. But the next stage, we wanted to be more business oriented. We wanted to give the customer an experience that was optimized for them. And we wanted them to be able to feel that they also had some empowerment in there. And as such, the next step would be actually to get all players involved, even customers or users, depending on your business, whoever is valuable. So the business needs to be integrated into this workflow. So how did we do this transformation? In 2005, we had about 35 physical machines for compute nodes, 15 physical machines for storage nodes, and 5 different networks. Most of it was based on VMware, and we set this all up. It was a mix of a lot of different machines doing specific tasks and specific things. Given that these machines were not able to fully utilize their capacities, it meant that of these 35 physical machines, not all of them were actually running at full capacity. At the time, we typically had about 10% CPU utilization in the compute nodes, and on the physical storage machines, we hardly had 20% storage utilization. So it was far, far less, but because of the way that we decided to install everything bare metal or based on VMware with licenses which were rather restrictive, it was very difficult to do much around that. Then the first idea of cloud came up, and this is actually when we started a different company. We bought over some of those machines. We combined compute and storage nodes, and we started looking at KVM from Linux. And at this point, it was still very early days. Most of production workload was still running VMware, but we started playing with KVM and exploring how we could actually get this up and running. And we even looked at Xen at the time. It's not mentioned here because we never actually had any production running on Xen, but we did look at it, and it was a very interesting time to try out things and to start new development. And then it took us about 2 years to figure out that we could actually migrate everything to KVM. And we wouldn't have VMware and its licensing anymore as a requirement. So we basically migrated within those 2 years everything from VMware to KVM. And beside that, we didn't do much because we were looking more at what the customers wanted and what their enablement was. And so the next step is actually when we started looking at clustering systems, at how we can make systems highly available, and how we can have a different how we can have different architectures to provide the same experience. So here we introduced multiple brands. We introduced our first different architecture, and we started to manage all of that, or we tried to manage all of that from one central point. Initially, that wasn't the case, so we had multiple control nodes, and initially there were a lot of things that we had to work around, but a lot of the things already made more sense because we had different machines. We had a little bit older machines, we had newer machines, we had different brands of machines, so we could actually test whether this works over different types of machines. We started looking at the things that today are referred to hyperconverge, where we were trying to get compute, storage, and network into one node and get them to utilize more of their CPU, more of their storage, more of their memory, so that utilization would go up and the number of physical machines we needed to actually have went down. This is also the time when we started migrating everything to a virtual environment. Initially, a lot of the databases were not moved to virtual environments. Those were actually the last ones to migrate. But the migration to virtual machines made it easier to actually have different types of physical machines, different types of architectures, and different types of placements of those machines. Then 2 years later, we were able to consolidate more of these machines. We standardized on one brand for the x86 machines, on the power, and we had more power machines now, and we introduced the Raspberry Pi as control nodes and as compute nodes also, so that we would actually have 3 different architectures. Of course, you know that Raspberry Pi is not a very performant machine compared to the other ones, but it allowed us to run specialized workloads or limited workloads on these little machines and have ourselves aware of how the different architectures can be used, how our software stack and our automation tools would have to interact with different architectures and different ways of working. And so more recently, we upgraded those Raspberry Pis with newer versions, which are 64-bit enabled, and we added some AI ARM versions of NVIDIA to allow some offloading on that end. This again means that we can use the specific system for its specific purpose. If a specific application runs best on ARM, we run it on ARM. If a specific application runs best on Power, we run them on Power. If specific applications run on X, we run them on X. And we want to have one management system to be able to deploy to all of these machines. We want to be able to run all of these machines in such a way that they are one cloud platform, but they also give one user experience. So if a user says, I need to have a specific application, for example, surveillance system that would require you to have storage. In our case, because of the way we have our data, our cloud set up, storage nodes are typically on x86, while the power nodes typically run more the intensive workloads. And we use the Jetson for some of the AI stuff because it's cheap, it does its work, and it basically can give us quick access to certain things. Over time, we will most probably change that also to power systems, but we will keep the mix so that we can actually see where specific workloads also work better. And then we can advise customers that this workload works best on this platform. Having the different platforms gives us that ability and gives us also the option to test this within our own stack of systems. So from a software perspective, it becomes a very big issue. So we have our own Linux distribution called PowerEL, which runs on the Power architecture, which also runs on x86 and on the Raspberry Pi. This means that we can run the full operating system stack and all other layers of that to our benefit. We can optimize for that, and we can run them as we think best in there. We also have a lot of workloads running on CentOS because it's very common. Customers typically like CentOS. We have specific applications which, from the application point of view or from our customers' perspective, run on Ubuntu or Debian because they want it. Also, for some of the newer web development, Ubuntu is preferred because most of the web developers prefer this. We run FreeBSD mostly for our ZFS interaction. So all the storage is FreeBSD with ZFS. That runs, or that used to run primarily on X. Now we have also running some workloads on Power for that. And OpenBSD we use for all its routing, so packet filtering. Arch Linux is specifically used on some of the Raspberry Pis to enable us to have 64-bit enablement, and some of the software there was developed with some other partners we have who have done a lot of work on Arch Linux, so we use those. So you see that there's a variety of distributions in there, which give us the possibility to run different workloads. It also gives us the ability to run or to accommodate the customers in such a way that they get what they are looking for. So we have some customers also running their own Linux distribution like SUSE for some of the SAP stuff, but typically we don't push that in our own stack. We will do that if the customer demands requests us. From an automation point of view, we chose to go with Ansible. It's a very good orchestration tool. It does also configuration management. Initially, when we started, we used BuildBot. We are migrating to Concourse, which is another CI/CD platform, which enables us to actually get a pipeline for our deployments. In our deployments, we use QEMU and Podman. So QEMU for the virtual machines with libvirt as the abstraction layer, and Podman with Kubernetes for the containers. We have a VM installer role, which is basically an Ansible role, which installs our virtual machines from scratch, fully customized to the needs of the application. On different parts of the machine or on different parts of the cloud infrastructure, allowing us to have the best system for each integration. We have a container builder role, which is basically a pipeline which builds the containers so that we can deploy them to our stack. And we have a whole bunch of Ansible deploy scripts, which is basically deploying the full application. So once the VM has been installed, we can run the deploy scripts, which will install, for instance, a Pretix ticketing system or a VT Commerce e-commerce platform, and get that fully with the right load balancer enablement, with the right Let's Encrypt certificates, with the full backup system in there. It will talk to our iSinger 2 for monitoring and alerting. So it will put that in high availability or into a normal cluster node, and we'll do the alerting accordingly. And to power all of this, we use Request Tracker as our ticketing system. So we chose not to build a fancy GUI or a web interface. Most of it just works through a ticketing system, and the ticketing system basically pushes our pipeline depending on what the user is allowed to do. And in such, we have a fully automated system as per the cloud. So we are able to give our users, our customers, a cloud experience, and they are able to get the best of each platform. And if the applications are known to us, we actually have deploy scripts which will look and which will deploy the application on the best platform as per our testings. So from a customer perspective, what does that actually mean? A customer can request a virtual machine, a container, or an application. And depending on which of these three it requests, a specific request will be created in Request Tracker, which picks it up. It will verify if this user is, of course, allowed to do any of these actions. Our Concourse CI/CD pipeline will start the implementation using Ansible or Cube, and will kick off the deployment. At that point, the machine or the pod gets deployed and provisioned. And if it's a pod, the application gets added to the load balancer through service discovery and becomes available to the user. If it's a virtual machine, it gets deployed. It will get the full application layer if that is what the customer wants. If it just wants the machine itself, it will give the user the credentials where it can log into. Afterwards, our backend, so Ansible in this case, will add it to the monitoring. We'll also add it automatically to our backup system, and the user gets an email with all the details. When we first started implementing this, we had about 2 hours from user request to user email. We actually have brought that down, and I did a test 2 days ago to about half an hour. So that includes the actual building of the machine. So we don't clone machines, we build them using the deployment system. Installing an application, in this case, a ticketing system, and putting all the monitoring, backup, and verification, user creation in there with the actual mail being sent 30 minutes later. We have that also for surveillance systems. It takes a little bit longer because it requires multiple machines and it's a cluster because it does a lot of the AI stuff in there. But we've got that down to about 45 minutes, which means that the customer or the user gets a full cloud experience in that way. So you don't need a cloud provider. You could use OpenStack, you could use OpenNebula. What your user is most, or what your business will be most interested in, is the cloud experience. And so we want to empower the business, and that is what we try to do and what we have been able to do for our customers. Thank you. And if there are any questions.